And welcome to tonight's TI Technology webinar hosted by Texas Instruments Australia. We are really excited to bring you Exam Readiness, Math Methods, Stage 2, SACE with Isabel Hoadley and myself, John Bayment. I am your host, as well as one of the panelists for this event. I teach mathematics to Year 7 to 12 students at Lachlan Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. I'm excited to introduce our other panelist for this evening, that is Miss Isabel Hoadley. Good evening, Isabel.
Evening.
It's actually a bit strange calling you Isabel, actually. As I work with you, I call you Izzy, so good evening, Izzy, as well.
Yeah, that's better. Thanks, John.
Isabel is a colleague of mine at Lachlan Catholic College in Darwin, as I've already said, and she's an enthusiastic and dynamic teacher. I have to admit, I am somewhat in awe of her biography, although completely justified when you see the professionalism she shows in her teaching and the respect her students have for her. Izzy, it really is fantastic for you that you could join us this evening, so welcome.
Thank you.
So that's the introductions out of the way, and let's get started. So probably the first point is I want to make sure that we all have our calculators on the same OS. So I'm just going to shrink my PowerPoint down for a second, and I'm going to shrink down my handheld, hide the side piece here. Here we go. So to make sure that you are on the right OS, whether it be the actual calculator itself or the smart view software that you're using like here, you go to Second Mem and About, and you see what the software is. So you can see here that I've got the updated operating system. If you want to check, you can go to the TI Australia website. Obviously, it's not like a phone that's connected to the Wi-Fi all the time or a tablet. You've actually got to do it yourself, but it really is quite simple. You download a piece of free software called TI Connect. You can see that here. And I'll just turn on the calculator I've got connected at the moment. It will come back onto the screen. There it is. There's the calculator I've got connected at the moment. I can show you again that I've already got, and I'll take a screenshot of my calculator. You can see that I've already got the updated operating system on my handheld, as I should have, I suppose. But we also can very easily update it. We just download the bundle, which is the TI Connect bundle, just like an OS, and there it is there. And I simply just drag and drop it. Really simple. So we're going to show you some of those features, but it's really important, especially if you started using the Innovator Hub or the Rover, you need the updated operating system, and it's that simple to do. It really is. You can also share it between handhelds, so that's really useful if you need to as well. All right. So let's got a lot of screens flying on here. So what is on the new OS? Well, there is a nice way of doing the piecewise function graph, and Izzy will show you that later in this webinar. You can also do sequence editors. There's much more a cleaner way of doing that, and that's really more so used for specialists or IB. There's some fantastic uses now for programming, some great undo buttons, which never used to be there for programming. So if you've never learned about programming, please look up the TI codes on the TI website. It really is fantastic, and my students are loving it at the moment using the rovers, the robotic vehicles. Sending files between each other, whether it be lists or programs or images, is really easy, just using a mini USB to mini USB cable. I'm going to show you the nice new feature of the interaction with the tangent. I can draw a tangent and save that tangent. And I hope we can also do fractions just a little bit quicker. And finally, transformations app that Izzy has shown in a previous webinar. So if you go to the TI website and go to the on-demand webinars, you can actually look at those as well. Wow, we got lots to get through tonight, Izzy. So when students start their exam or a test, or even just in class, one of the main things is the error messages that can come up on their screens. So probably an important thing is to reset the calculator. One way is to reset everything. That's called all RAM, or really you can just reset the defaults. So what I mean by that is that they may have plots on, which may mess things up. They may have something in y equals that may mess something up. They may have a window that doesn't make sense. Let me just change these numbers here to say 50. And they have some numbers in here that don't make sense. If they go into second men and go down to reset, go to defaults and reset defaults, it just sort of puts the calculator back into the sort of normal mode. The y equals has been turned off, all the stat plots are now off, and the window goes back to the regular 10 by 10 in both directions. So that's probably the easiest one without having to reset the RAM, but that does a bit more of a serious thing to do. All right, so you should be aware of the quick keys. If you weren't, wow, there's some really cool stuff in the quick keys. That sounds sad when I get excited about this, Izzy. Please stop me. There's, in alpha, so I'll just show that again, in alpha F1, so using the function buttons on the top, there's all the fraction stuff that you may want to use, both top-heavy fractions and mixed fractions, conversion between top-heavy and mixed, and fractions and decimals. In alpha 2, I'm going to use a lot of this tonight. A really nice one is obviously logs to whatever base you want, and powers. Now we can find that in other places, but this is a much quicker way to find it. We can do a quick matrix. We can't save it as an actual matrix, but we can just do a quick one if there's a quick calculation we want to do. And there's where we can get all our graphs if we want to. And again, I'll show you that. At the moment, there's nothing in F5, although if you're using programming, there is. So you could argue that there is. So I've sort of contradicted myself on that one. These are the graphs that I'm going to show you tonight. And I'm going to show you perhaps as much of the calculator can do with all of these things, both a regular polynomial, a surgeonadistic function, using trig functions, composite functions in the graphing screen, talking about the difference between obviously integral and area, which we know in the SACE course and hopefully other courses as well. They really distinguish that really nicely. An area between two curves and how we can do that more efficiently. So this is what I aim to cover in just this polynomial that we're going to use, which, there you go, that's sort of setting the bar a bit high on that one. So I'm just going to move things across a bit. Just messed that up, so I moved the wrong thing across. Let me just set that up a bit clearer. All right, so I've just split the screen on the smart view to make it a bit easier, and I'm going to make it full screen in a second, but I'm going to cover all these things, and let's see if hopefully I don't miss any. If I do, Izzy, please shout out. So the first thing is that there's that polynomial that we're going to use. So I'm going to make it full screen now. That's probably pretty nice. And I use this smart view in my classroom a lot, and really great if you've got an interactive whiteboard, because you can now just touch the keys on here. And it's really easy to explain to students what button pressing you're doing. You can have the history on the bottom and shrink that history down. I think that students find that confuses them a little bit, but you can have that if you wanted to perhaps do a tutorial. So let me show you how that will come up like that. But I don't really use that very much, but I definitely use the interactive whiteboard and press the buttons. So we've just got to turn that on. At the moment it's off, so we come over to the equals and press enter, and there it is. If we go graph, there's that beautiful polynomial. We're just going to tidy it up and make it look a bit nicer between -5 and 5. Be mindful some students will type in take away 5, and when they try and graph it won't. Interestingly on this, that they'll always, for some reason, a lot of students choose quit rather than go to. So make sure they go to the error, and it will tell them what the error is straight away. So much easier. And there we go. All right, so we're going to do a value. Well, that's pretty simple. So I can calculate a value at whatever x value we want. Let's choose x equals 1. There we go. X is -3. That's pretty easy. We could also go into table, and there is the same value at x equals 1, and the value is -3. So we can use this. Don't forget, a nice underrated feature of the table section is actually going into table set and changing what you start at and what you go up by. So if you're looking at a bigger graph and you want to do it, this is a really nice thing. It doesn't look any different on the graph, but if you go to table, we can see now it goes up by 5s. So a really nice feature of that if you want to change that around. And there is a quick way of doing that as well. If you actually just have a look on the screen, you'll see a quick way of doing that as well. All right, so we've got that curve there. So we've done value, we've done taking. Yes.
Is there a way that you can see the table and the graph at the same time?
There certainly is. I was thinking about that and I thought, oh, will I? So in mode, and that was another thing I meant to mention, thanks for that, Izzy.
That's all right.
Is when we did the default, it turned it back to radians. The nice thing is it will stay on the top of the screen now. And we can change any of these. I've just been doing some parametric equations with my Year 12 specialist students, so I've been using this one. Obviously, most of the stuff we're going to do is in radians, but we can use degrees. But a really nice feature that Izzy's talking about is coming across the graph table. And when we go into graph now, we get the graph and table by the side of each other. And if we press table, we go onto this screen, so we can go through all those values. And look how nice it is with actually showing the value. You can see that it says press plus for the table increments. So again, we could press the plus, that's what I was mentioning a minute ago. We change it, say, to 0.5. And now again, that's a really nice little feature. Do you use that very much, Izzy?
Yes, I have used that quite a lot. I probably used it more with my general students last year that struggled with solving equations more than my method students this year.
Yeah. Very cool. So I'm just going to turn that back, but also there's some other nice things in format if we wanted to add some grids to that. So we can actually add some grid dots or grid lines if you'd like to see it like that. And those grid colors are controlled by the X and Y scale on the graphics calculator. That can be quite useful. Probably better if you're doing zoom square because they actually look like squares. But I probably normally keep those off unless they're suitable for a certain thing. So go back to 6 again, go back to my window, change that back to -5 to 5, back into format, just going to turn those grids off. Okay, there we go. Any other questions at the moment, Izzy?
No, that's it for the moment.
Please keep those questions coming in. It really is, we do aim to answer those. So next thing is finding the zeros or the roots. Obviously, a zero is if the function was equal to 0 and it was asking for a solution, and a root is when the polynomial is 0. So sort of the same thing, but subtly different. So we go for a 0. One way is to press enter. That will give me an arrow here, and then move to the other side of that value and press enter again. I can be bothered to guess because there is only 1 0 between those two arrows, and here it is now, it's 1.33. Now, I may want to use that number later. So I'm going to label this one A, the second one B, and the third one, shock horror, C. So let's quit that, and the calculator remembers the last number it had for X, has last storage. So there it is, that same number. I'm just going to store that using the button here to the left next to the 1 as alpha, and then press C. So that's now stored as C. Go back into the graph again, do the 0 again. This time I want to do this one. Well, I know the scale goes to -5, so it's somewhere between -4 and -3. So a much quicker way is just type in -4 and -3. Is it between those two? Yes, it is. There's my second point. Notice that if I now type in X now, I'll just do it a quicker way, but typing in, the X changes because the calculator keeps updating that storage of X. So I'm going to store that as the first one, and last one, just in case I'm going to use it later, 2, somewhere between -2 and -1, so -2 and -1. That looks good to me. Enter, and let's just quit that. Let's store that one as B. Love the store button. Fantastic. All right, so we may use those in a minute. Minimum and maximum. So very similar as to before. Calculate. Let's just choose one of them. Let's go minimum. Well, we know the minimum is somewhere between there. That will do me. And 1. So again, I can just be lazy. Somewhere between there. And here's the minimum value. Again, I could store those if I wanted to. I don't think I will this time, but I could do. Again, if I wanted Y, go alpha, Y, and there's that number that was on the graph as well. But I'm not going to store that. It will just keep writing over the top of it. So unless I do something with A and B will stay these numbers until I end up doing something else. Another way, obviously, that you probably wouldn't do as much on a graph because we've just found the minimum, is to find the derivative of this and then put it equal to 0. So that will give me a quadratic. We can do it several ways. One of the easiest ways to do it into here, we're going to use the quick key, alpha F2, derivative, differentiate with respect to x of this first equation. So again, that was in alpha F4. We're going to differentiate it for which value of x? Well, for all values of x. And there we go. So if we now graph that, we'll see that it gives us a nice quadratic. And we should see that that 0 value is the same as the minimum there. Now let's just see if that was true. Let me just see what the last x value was that I stored. Why did that come up as 5? That's interesting. So let's go back and do the minimum again. Somewhere between there and 1. No, I'm not going to bother guessing. Thank you very much. There's the x value, 0.29. Let's just leave that like that for now. Go back to graph. Let's look at this 0 here as well. Second calc, 0. Now it's not the blue line, so arrow down to get onto the red line, somewhere between 0 and 1. And can't be bothered to guess again. And there it is. And we'll see that although it looks like it's the same x value, it's found a completely different way. So there's the 0 on there as well. We can also look at the second derivative in the same way. To do that, follow it pretty much the same as before. So we'll use the quick key. Notice that alpha locks on this one, so we don't need to worry about, we could use any of these letters, but I'm just going to use x. This time, obviously, we're differentiating the second one. Also for all values of x. And we'll see that we get a linear. And I just love this. I just love the fact that we've got colours now. We've got the 3 different colours, and we can see how they all change in relation to each other. Using that split screen that Izzy mentioned earlier and actually having table to the sides and showing varying the points is a really nice little feature. And of course, we now know that this value here, the 0 of the straight line, is the non-stationary point of inflection of that cubic. So I could find that, but that we can follow through. All right, so I'm going to leave those there. I'm just going to turn them off. So come down to them. Just going to press Enter to turn that first one off, and Enter to turn the second off. Notice that they've now got no black rectangle around the equals, only the cubic will get drawn. And we're now going to draw a tangent. This is what my year 11s are doing at the moment. Obviously, they have to do it using differentiation in calculus and finding the x and y. They've got the x value given to them. They find the y value. They then find the gradient at the same value. They've got to do it by hand. There's a really nice check on the graphics calculator. And I think that SACE has got a really nice balance how they allow the calculator, but students got to do a lot of the questions by hand, either because they use algebra in the questions for variables, or they say exact values. But I love the fact we've got this nice balance and that we can actually use the calculator to support students' understanding as well as grow their confidence, especially in an exam, which is really important. I think that's part of what we're there for. So, okay, this time now we're going to go into draw. Go into draw, and you'll see that we can draw horizontal and vertical lines. We can also draw a tangent. A new feature of the OS is this menu button. Now, normally, it would obviously be up here, so it's linked to F5. So if we press this function button, it will give us this. So let's change the screen back again. There we go. Do I want a blue line? No, because I've already got a blue line, and let's go magenta. Beautiful. The line's called like that. Tangents. Where do I want to dump the tangent? Well, I've already got Y2 used. I'm just using the arrows here, and I've already got Y3 used. Let's put it into Y4. The important thing is you come down to OK and press OK. Now, nothing looks any different, except that we've now got to type in the x value. So I'm going to choose x equals -2. Beautiful. Look at that. And students sort of see that now because they know that I'm an idiot in class, surprisingly. And I put a ruler on my head balancing to show that that's a tangent. Well, hopefully that's what they think, and they don't think, oh, that teacher's a fool. But hopefully they remember that's find a tangent. Probably maybe both. Izzy, careful now. Thank you. We can also now find the intersect really nicely. A really important point, just notice here that there's a bit of rounding error going on. that's really important that they understand that that's minus 2x minus 1. Also useful on assignments where they have to talk about limitations and, what's the other word? Is it? I've forgotten for a minute.
Assumptions.
Assumptions, that's the one. Thank you. So we could go up into here and just below it write the nice, neat version of the same question. And we should see that the green will go over the top of the pink. And if we went into table, we could see that those two values are the same. So we've done everything spot on. Just here, you can see there's just a little bit of rounding here. All right, so I'm going to find that intersection point. So second calc intersection of the blue curve. Enter. And I don't want the green one, so arrow, sorry, I didn't want the pink one, or the magenta, sorry, so arrow down to the green one, press enter. This time I am going to guess, because obviously it will give me this one, so I want to arrow towards the other one. So I do want to get a guess now to make it easier for the calculator. And there we go, we get 1 minus 3. Let me make a note of that. 1 minus 3. Cool. So that's a really nice feature of the new OS. I'm going to turn that one off too now. Right, where are we up to? Finding the gradient at a certain point.
John, just quickly, sorry, if they had like say for example put the tangent in incorrectly and they just wanted to quickly get rid of it and redo it, is there a way that they hadn't say stored it yet or anything? How would they do that?
I don't quite understand the question. If there was, let me just say. So one way, obviously, is to clear. Well, let's say it was. Let me just turn that one off. One way is to just turn off or clear it.
Yeah.
Are you saying that if they're in it, so they go into draw, and they're in tangent, I'm going to just use the menu and just change the color to something different. We store that as say Y5. Are you saying in this screen that you want that they do something wrong, or is it later on?
Just within the graphing screen.
Just here?
Yes.
Yeah, so if they type in, well, first if they type in -3 instead of -2, then that's okay because we can clear that. We haven't pressed enter yet. But as soon as we press enter, it's done.
Yep.
Is that what you're asking?
Yes.
Are you sure?
No, but that's okay.
Sound like a student. Okay, right. So we've done that gradient derivative at a certain point. Well, again, there's two ways. One is to use the derivative section here, number 6. Let's just choose it at, I don't know, 1, let's say. So if we find the gradient at 1, we can type it in here. And there it is. There's the gradient. Again, students realize that that gradient is 7. We can also do it in normal calculator screen. Let me just clear that, make it a bit cleaner. We can use the quick key, go into derivative, x of, what was the graph? It was y5, if I remember rightly. Add x equals 1. And that doesn't look right. What did I do? I did it of the wrong one. I'm supposed to be doing it of the Y1. There we go. So go back over here. No, she didn't say yep until I'd actually made that mistake. See, that's how. Leave me there. Okay, Y1. Here we go. There it is. And there's the slight rounding. And then we get students to realise that's just 7. And again, examples, I don't know, I'm really impressed with how they come up with these different questions. They know that there's going to be rounding error. So you've got to make sure we educate our students to say that, well, that is just 7. It's not. You wouldn't write down 7.00 5 times in 1. All right. So back to graph now.
And you can just input an equation in there as well, can't you? Instead of using the Y1. Yeah.
Yeah, that's right. Yeah, that's right. Yeah, we could have either typed that polynomial in, or if we wanted it, that's not a good. Let's just do something. Say x squared. Plus 5x, or 8x there. That's going to give us 2x plus 8. That's going to give us 10. There we go. So that's another way we can do it. Yeah, thanks, Izzy. Nice point. All right. So now if we look at the integral, we want to find the area. Well, let's look at the to start with just the polynomial. I want the area here between these two values. I've already stored those as A and B. So back in this calculate integral, lower bound, I'm going to use A because I've stored A as my lower bound, and it will come up there. And now our upper point, which was B, and there you go, there's my answer. Integral is 4.166. Same as before, we can also do it in this screen. Either, like Izzy said, we can type it in by full, or we can just do the shortened way of doing this same question, which is just doing it using Y1. Yeah, and it's quite nice, isn't it, to actually get the students to type in the equation here, because they trust it a bit more, I think, than just seeing it written like that. I think that looks just a bit more, oh yeah, I'm happy with what's going on. So I think that's a really nice point.
Yeah.
And there's that same number that's come up. Obviously, what the exam boards, and especially SACE, want to distinguish is the difference between integration, which is just obviously taking into account positive and negative, and area, which is just looking at positive. So we know that the integral between, say, this value, which was C and A, is not the same as the area. So second calc, but let me just do it first of all between, say, B and C, and we get that area there, which we know is negative. If you don't like this clear color, you can actually clear it. You can go into draw and do clear draw. If you really don't like it there, you can get rid of it. There we go, it's gone. But if we do it into calculus time, then we want to do it, say, between here, C and A, so between A and C. The integral is that answer. That's okay, the integral is that answer, but the area is not. The way that I like to do it, we could either do it in normal calculator screen the same way, but I quite like doing it in the y equals screen. And I'm just going to come down to y6, and we're going to take the absolute of y1. The reason I like doing it this way is I like the students to see the graph made, and we can see it there. How cool does that look? Now we can go second calc the integral. Just got to make sure we get the right curve. Yellow one, or orange, between A and C, and we can see that it does give us the right answer. Woohoo!
Beautiful.
It is, isn't it? All right, last one on this. I'm conscious of time, Izzy, so I do apologise. That is, let me just go clear draw as well.
Sorry, John, you've just got a question. There's a question coming in that asks if students struggle with understanding the modulus or the absolute value function when you teach it in that way.
Yeah. Would I teach it that way? I think that the graph of showing it bounce back up and be the same graph up in the positive side is a really nice visual and a really nice reminder for them anyway. I think that if they weren't confident, then probably what I would do is get them to do it on this screen, get this answer, and then also repeat the same thing, but change the A and B, obviously, to B and C.
That's the way I do it in class, just because we don't do a lot of absolute value in the methods course at all. And
then you can obviously do it like that, and then you're going to get the same answer.
Yeah.
And I think that that's quite a nice way of clearly showing it. And it's nice because obviously lots of those questions will be exact value questions. They can just use that decimal to check that they got the exact value as well if they have to do it with non-calculator. So I like the fact there's one exam, and I like the fact that the calculator is blended, that they have to work out when and when not to use it, but they definitely can use it to supplement some of the stuff.
Yeah.
All right. I'm just going to do two more things, and then Izzy, I may pass over to you and hold back on the last couple, because I think within reason I've shown the graphing of most of the derivative stuff. Probably what I'll do is just three things, and then I'll pass over to you, Izzy. One is if we were going to do the derivative and want to show it by checking that, say, the derivative that we've got is the correct one, what students could do is we know that the derivative of this one is So they've worked it out is 3x squared plus 6x minus 2, and they wanted to check that that is the correct one, and they've obviously done it by, just going to turn that one off for a second, they've obviously done it by hand to see if it is. So I'm just going to show you that we could just turn that one off. There's the derivative drawn. Cool, that's okay. We go back in, we're now going to turn on what they think they've worked it out to be, and they're going to see if it's the same. We could just draw over the top and use pink, but it's going to be a bit vain here and say, well, you can change the line to this nice tennis ball one. I really like this tennis ball one. May even change it to just that tennis ball one. Come down to here, press OK, and if we press graph now, it sort of moves along. I like that. That's a nice little feature. Carol Mill uses it really nicely in parametric equations. And if we go into table, we can see that the values are matching. So we go, yes, well, my derivative was correct. I'm a legend. Move on to the next question in my exam. So that last two things is obviously the area between two curves. I'll turn back on the original. I'll turn off the first derivative, not that. Turn the first derivative off, turn that one off, and turn the tangent back on. So if we were wanting to find the area between this line and the blue line, just this area just here, again, we'd have to find these values, which I think, so I remember off the top of my head, are -2 and 1. So again, we could do that in normal calculator screen, because we could go the integral between -2 and 1 of the top line, which was, oh, that's got me thinking for a second, y5 minus y1. So come over here, y5 minus y1 with respect to x. Oops. And that will give us the answer we want. And we could also do that by graphing. We could also, in here, graph y5 minus y1, and it will drop it down to the x-axis, and it will just draw it down here, and we'll be able to find it the same. That's a really nice little feature as well. And finally, is composite. If we were wanting to do composite, well, let's take an example of composite. Let's say we're taking this one and we wanted to sub y1 into it. What we could do, let's turn that one, I'll leave it on, doesn't matter. If we're doing composite, what we could do is we would go -2. We want to replace that x with this one, so say gx. So again, just do it the same way, replace it with y1 minus 1. And I find that's a really nice thing for students to see. And if they can graph that and they get their composite graph. Wow, there we go, Izzy. I reckon for now that will I will pass over to you. And if we get time at the end, then we can actually look at some of the other things. But I think that I've covered most of what I wanted to cover and given ideas of that store function, which I find really quite powerful, and obviously the different things we can do on the graph. So I can see your screen. It's all yours. Over to you, Izzy. Good luck.
Beautiful. Thank you. All right. So as John kind of said, he's focusing mostly on the function side of methods, and I'm going to talk a little bit about statistics and also some of the applications that students can use to help them in an exam. So the first thing I'm going to think about, the other thing is I've taken a different approach. I'm going to look at some more kind of SACE exam style questions. So a lot of these questions are ones that I've adapted from past exams. So the first example we're going to look at says the table below probability density function with discrete random variable x. We want to find our missing variables A and B in our probability density function. So the first part of the question is explaining why A plus B equals 0.7. Hopefully students remembering that all their probabilities have to add up to 1. The second one says that given that the mean equals 2, we want to write a second equation for A and B, which I've done here just to save going through the working out. So we have our second equation, which is -3A plus B equals 0.2. The next part is asking students to find their values of A and B, and from here they will have to use simultaneous equations to find those two missing variables. So we can make this a bit easier using our calculator. In the apps menu of our calculator, if we go, sorry, I should just say I went down rather than up, up rather than down, because the app I want is towards the end of the menu. So I'm after number 9, which is the Polysimul 2 app. So in here, we could use Route Finder. John showed how to find zeros using the graphing menu. You can also find zeros of functions using the Route Finder, and I'm going to do that later on. But I want the simultaneous equation solver for this problem here. So we've got 2 equations and 2 unknowns. And to go to click onto the next screen here, you do have to use the white key, so the graph key, to do that. Now, I've already got my systems of equations put in from when I was practicing before, but students can edit that, just remembering that they do have to use a negative if, for their first variable. If the second variable is a negative, they can just change the plus to a minus, and they are using the subtract key then, but if it's the first one, they do have to put that in as a negative, otherwise they'll get an error. So we can go to solve, which is the other graph key, and one of the things I really like about this app is that you've got that ability to change your solutions between fractions and decimals. So in this problem here, we're given our third probability as a decimal, so I'd probably encourage students to also give the other probabilities as a decimal as well. So we're just going to tab in between fractions and decimals, and we get our 2 probabilities. However, if we had given that as 3/10, we could also just go back and we've got our fractions nicely there that students can see. Okay. So there's the values. I've already put those into my list on my calculator. So there they are. We've got -3, 1, and 6, and the 3 probabilities there. In here, we can go through, calculate the standard deviation. I believe in this exam that this was actually a 3-mark question, so with the, I usually tell my students that anything more than 2 marks, they're really asking for a handwritten answer, one that shows more working out rather than just a computed question. But if we wanted to confirm our answer, there's 2 ways we could kind of go about calculating the standard deviation. The first one is using the calc menu of the stats function, and we're looking at our 1 variable stats, our list 1 and list 2. We can calculate that, and we get our mean, which we already know is 2, but that's nice to kind of see that confirmed, and our standard deviation, which is 2.915. Another way which I really like students to actually go through and calculate standard deviation is to use, in the list function, to use the math menu. So in our math menu, I like them to use this because I think it creates more of a connection between what our actual formula is for standard deviation and what we're being asked to do. So if they are finding standard deviation, I like to actually get them to use the sum function. And then obviously for our standard deviation, we're looking at our list 1, or our x value squared, times by the probability in our list, by our probability, which is in list 2, and then minus our mean squared, which we already know is 2. And we get that, and we get 8.5. That's going to give us the variance, and so we take our square root. And there it is again, the 2.915. And again, I like that because it's still kind of putting in the same way as you would work with equation, but without them having to go through that laborious inputting all the different variables. Okay, so the next question we have, this is, again, it's in quite a similar one, is one that was in our exam last year. So the problem says, for a student to pass a particular course, they must pass at least 4 out of 6 tests. For each test, the probability of the student passing is 0.75, and we're given our first 4 probabilities, but we're missing the last 3, which we need to find. Now, for this, hopefully students realise that they're looking at a binomial distribution, and they could go through, we're looking at PDF because we want the probability where it's equal to rather than an inequality. And we could look for this and say we've got 6 trials altogether, a 0.75 probability and an X value of 4, and calculate that, and that would get put into that table there. And we would have to do that 3 times for 4 and 5 and 6. However, we can also use lists to do that a little bit faster. So in here, I'm just going to, if it was anything probably more than about 6, I would tell students to put in a sequence, which I'll show you in, oh, I put in 4 twice, 5, 6. I would get students to put in a sequence there, but because we're only looking at a few numbers, it's probably just as quick to input them. Then in our list 2, I'm going to clear what's in there already and go up, and in here we go to our binom PDF. In there, we've still got 6 trials altogether. Our probability remains the same, 0.75, but instead I now want to calculate the probability for every single value that we're given. So in here, I'm going to put in list 1, paste that in there, and we can see that our table comes up with all of the values, not just those 4. And it's nice, I think, for students to be able to look and see that second probability is 0.0044, and that's what they have in that table there. The other thing that we can do here is, again, using that sum function, is we can just confirm that all of those probabilities in list 2 are going to add up to 1 at the end, which they do. I had some students the other day, actually with the next problem I'm going to show you, where some of them were struggling to get the right answer, and I said, all right, we'll add up all the probabilities in your list 2, and you can use that sum function, and that did turn out that they had that all their cumulative probabilities were greater than 1. All right. Okay, so then, sorry, must be the next problem after this one. Okay, so the next one says we've got a factory manufacturing dumbbells which are labelled as weighing 2 kilograms. It's a normal distribution, and any dumbbell lighter than 1.995 or heavier than 0.005 kilograms are going to be rejected. We know that our probability in between these 2 values is 0.96, and we want to find our mean and our standard deviation. So this is, again, a time when we can use our simultaneous equation solver to help us out a little bit. So with this question, I find my students find these really, really hard where they're not given the mean and the standard deviation. And it's quite hard for them to connect, so I'll just do it here, the Z variable equation with then making their systems of equations. So to get our Z variable, we are, sorry, wrong one, in our distribution, we want to use our inverse normal because we know our probability, but we don't know our mean and our standard deviation. So we're going to keep that as 0 and 1, and we're just going to change our area to 0.96. And in this case, we're given 2 X values that we know between. So we're going to use the left, we're going to use center instead of left or right, which is what we've already got it on. I found now that being able to have the left, center and right options, students have really not struggled with inverse normal as much this year as they have in the past when that hasn't been available when I've taught the course. So in here we've got our 2 values of negative 2.05 and 2.05, and we can set up our systems of equations. Again, we can go into our apps, into the simultaneous equation solver. Again, we've got 2 unknowns and 2 variables, and we can have our negative 2.05 x, that stays as 1, 1.995, 2.05, 1, and 2.05. Okay, and we can solve that, and we get our mean and our standard deviation. What I would like students to do, and what I usually get them to do, is when they're setting up their equation, they actually highlight that mean is going to be, in these equations here, that mean is going to be the y, and the standard deviation is going to be the x, just so they don't get confused, but it should be fairly obvious from there. Okay, so this is the question I was talking about before, which is one that I have taken straight from last year's exam, and the reason why I think it's a really, really, really good question, especially this part C, which I'll talk about. So we're looking at having different discounts given out to customers in a shop. Their discounts are all placed in a bucket, and we've got a certain number of balls labelled as a percentage discount. We want to find what the probability is that our customer is going to draw the ball labelled 100% discount, and then we're going to do a binomial distribution to find the probability of customers. I'm not going to go through that again, but I do want to focus on this part C. So the shop owner could offer an alternative incentive in which a 15% discount is given to all customers. And we want to work out which one in the long run is going to be more cost effective. And this is quite a simple question, which is just looking at mean. And my students were really stuck on how to answer this. We did it a couple of days ago in class. And we kind of broke it down and made it a bit simpler. And they eventually came up with the idea that they would put their values into the list. So, and just to kind of organise it a little bit more, so we have our 100% discount, our 50% discount, 25, 20, and 10. There's 1 out of 50. And here are all of our probabilities. So once we kind of put that in there, some of my students said, oh, okay, well, we can see we've got different probabilities for each of these things occurring. And so if we just calculated the mean, wouldn't that give us an indication of which one was going to be better overall? And it took them quite a long time to get to that stage because they were really struggling with the fact that they didn't actually know how many customers were going to be coming in to the shop. So again, in our list menu, we can go across to math. We can look at our mean, and we want to calculate our mean of our list 1 and our list 2 together. And we end up with 16.2 being the expected value for our discount across all of those customers. So obviously less cost effective than the first one. The other thing I did with this question with my students in class was we did a probability simulation on this to see how this would work in more of a practical sense rather than a theoretical one. So I'm just going to make my screen a little bit bigger. John, am I sounding all right over there? I haven't heard anything from you. Hello?
You certainly are. You're looking great. Yeah.
Okay, cool.
I had you on mute because the bush turkeys are going a bit crazy outside at the moment, just throwing the mulch everywhere. So I thought it wasn't appropriate to let everyone else hear the prehistoric noises coming from my garden.
All good. Okay, so to get to a probability simulation, we're going to go into apps and we're going to use number 0, which is the prob simulation. So in here, I really like using the spinner for these kind of problems, and I'll show you why. So if we go down to the spinner, in spinner we can set using the zoom key, remembering that those white ones correlate to the graphing keys at the top. We use the zoom key, and I want to make, because there's 5 different options of probabilities that we can have, I'm going to create 5 sections on the spinner. And in advanced, we can also change the weighting of those probabilities. So I'm going to say 1 is going to be the 10% discount. So I'm going to change that to 35. 2, I'm going to change that to 8. 3 to 4. And 2 and 1 being the 100%, which is at 5. So now if we get, yeah?
I find that's a fantastic way to do, even with junior school students, and using the simulation with SmartView. Just when you change it just subtly, and to start with they think is a fair dice or a fair coin, and then as you obviously increase the frequency, they start to see, hang on a minute, this doesn't seem quite right, is that right? And then it's a really nice little feature.
Yeah, and you can pretty much adjust all of those probability simulations. You can pretty much adjust all of those to manipulate it in whatever way you like, which is really good.
On this one, it's very obvious because the spinner changes division and what it's cut up into, but with the dice, it's sort of hidden underneath the engine, so to speak.
Exactly, yeah. So in here, we can spin it, and this is, I got my students to spin it about 300 times. I'll just do maybe 200 just to save, because we are running a little low on time. So here we've got our 200 spins and the result, and we can see obviously we're going to have a lot more in that 10% discount. But what I like about this is you can actually see more what the distribution of your graph looks like. So when we were doing this problem before with that, this part C part where they're comparing the different averages, one of my students, actually one of my best method students said, oh, wouldn't that average just be 10% because you've got the most balls as a 10% discount? And I was really quite surprised that that was her way of thinking. And so what I like about this is that you can see straight away really visually that although you've got most of those results in that lower value, we do have that skew towards the positive end. And in here, the other thing I really like about this is we can save this data. So if you go escape into data, we'll save it. It'll save in spin and section. So we'll quit yes. We're going to get out of here. And then if we again go to that mean using that the mean from the stats menu, And if we go back into our list, all the way at the bottom of our list menu, I'll go down to the bottom so you can see, we've got those sections and spins. So I want to work out the mean of those 5 sections. And we can see we get 1.82. So it's obviously, because we're using 5 to represent 100, we're not going to get the exact mean like we did before, but we can see that our mean does fall in between our 10% discount and our 20% discount, which I think is really nice. Okay, the next thing I was going to talk about quickly is just looking at continuous probability density functions. I was going to show in this question here the fact that we can use, sorry, I'll just put my calculator screen back. We can use the integral function, sorry, in F2, like John was showing before on that home screen, and say we want to go between this one, 1 and 0 of I don't feel like I have plenty of time, so that's all right. There we go. So we want x over 3 dx, and then we could add on that second probability as well if we would like. I'll just do it quickly. So we'll calculate that, and then I want to add on, I'm going to copy my function from above, and I'm just going to change that x to a 1 to get the third. And we can see we get a 0.5 probability. And that's a good starting point for students, because then they don't have to integrate all of those together. They know automatically that that last integral has to equal 0.5 to add up to 1, and they're just calculating that last a value. So if they go through and do that, we have our nice equation on the side, and we can see that we have our quadratic, and we want to find our value of a. So we can do that using the that same polysymbol 2 equation solver, but instead of the simultaneous equation, we're going to use the root finder. In here, we've got a quadratic, and I've already entered it in here. So we've got, I put in negative 0.5 because I find that's what my students will put in. They won't put in negative 0.5. They'll put that in as negative 0.5, 6 and 16, and we can solve that, and we get our 2 values, which x is 4 and 8. And what I really like about this is that they have to work out that 8 would actually lie below the x-axis, so that's not going to give them the correct probability, and the right answer is 4. To do that, I would encourage them to graph both of those answers. So I'll just show you, because 4 is the right answer, we'll graph with 4. But one of the nice things about the new OS on the TI is that we can graph this piecewise function quite easily. Now, I would encourage students always to put in the piecewise in the home screen, just because if you put it in the y equals, sometimes you can't see all of the pieces at the same time. So to get a piecewise function and put it into the home screen, we're going to first use the quotation marks. So alpha plus gives us that. We're then going to go into the math menu and scroll up to get to the right to the bottom, and we're going to use that piecewise function. We have 3 pieces all together. And we come up with our piecewise function here. From here, we can input our formulas. I was just thinking I should have, yeah.
As you're doing now, somebody asked about the inverse norm that they couldn't see on their calculator, the left, center, and right. So just for people, whether they're watching live or on demand, that's because they haven't got the updated operating system. So just make sure that, same with this piecewise, that you have the 5.3 OS. If we get time, I'll show you at the end, but I did show you at the start how to find it in memory to see that you got 5.3. And it really is a simple process, and you can also share it between calculators just using the link function, which you can see just to the left of your alpha, sorry, to the right of your alpha button, just above the X key. Notice that Izzy's doing this. She's getting the inequalities from test, which is just above math as well. So some students will ask what that is. And she's also using the quick key, which is fantastic for fractions, which is just alpha and then the X key. Izzy, you're showing you're kicking goals there.
Thanks. Yeah, so you could also use the inequalities from condition, but most students just find it easier to put it in from the test. And we use the piecewise functions a lot this year in methods when my students were doing their roller coaster assignment, for anyone else who's doing that, just so they could quickly, because a lot of the time they can't be bothered logging on to GeoGebra, and so they would just use it to test whether they had the gradients correct at the right points and whether they connected. Okay, so we've put in our piecewise function, we've closed the quotation marks, and we're going to store that in our Y1 again in F4, so that will come up into the Y equals. So we can calculate that. Then we should see it in Y1, and you can see from there that you can't see all of those pieces at the one time, so it is nice to put it in the home screen, I think. We can then graph our function, that should look like, and you can see here obviously the probability density function, so we need to adjust our window. So we're going to go from 0 and 5, and then from 0 to 1 in our Y scale, and then we can really nicely see that piecewise function. I put in this last part of the question, so would you expect the median or the mean of X to have a greater value? And I put that in just because I have seen a couple of questions like that in the past. So if they're finding their expected value, they know what their mean is from that. And if they say worked out their mean to be, actually, we'll calculate the mean using the integral. So if we go to F2, again, selecting that integral function, we're looking at from 4 to 0, and then for our mean, we're looking at X times by f of X, which is up here, so we can just go straight into Y1, and this is really nice because I don't have to put all of that in there, calculate our integral, and we get our mean at 2.05. If they wanted to compare this in our graph, we could again look, go second and calc, and we can look at our integral, and we're looking at from 0 to 2.05. And we can see our area there is 0.51, so it's just slightly greater than the median value, which would be at 0.5. The last thing I was going to talk about quickly was confidence intervals, and I won't focus on this, but I'll just show you where to find them. So both the confidence interval calculations can be found in the stat menu under tests. We're looking at Z interval for a normal distribution, or one prop Z interval for a binomial distribution. So if we just quickly, I'll just show you in the Z interval, if we're looking at a normal distribution, you can either enter data, so using the lists, or you can just straight away enter the statistics. And what's really nice about this is that you can change the confidence interval. So we can make that a 99 or whatever confidence interval we want to look at and then calculate. And that did not work, I think, because some of my values were 0. But you get the idea anyway. Okay, John.
Do you want to show that again, Izzy?
Okay, yep, sorry, I'll show it again. So again, in stat, in tests, if we're looking at number 7, I'll just quickly, we'll change the mean to 10. Say we've got 20 things in our sample and calculate. And there we go, we get our interval. So that's our lower and our upper values of our confidence interval.
And like you said, the nice thing is that you can actually use data and they can put it into stats, edits, and they can use that instead rather than having to work out those values first. It does it all for them. So that's really a nice little feature as well, isn't it?
Yes, yeah, it is. I'll just quickly show that. So if we go into data, you can just see the only difference is you're entering your list 1 and your frequency, so you can change that as well.
Fantastic. Was there anything else that you wanted to show, Izzy, tonight?
No, I think that's it for tonight.
Right. Well, thank you very much. Hopefully that people have felt that they've learned something new. I know that we've actually had a few people watching who use CAS technology, and they were saying how they've been impressed with actually what they can actually do on these calculators these days. And I think that's a really nice feature of this. So thank you very much for joining us this evening. Izzy is watching the chat window as we start wrapping up. So if there are any questions, then please send them in. So we do want to try and answer those questions for you, and also we can add them to plan for future webinars. So when we do leave tonight, a brief survey will automatically appear here in your browser, and your feedback does guide us as we plan for future online events. We do listen to your feedback, so please, we do hope that you share your thoughts in a post-webinar survey. And importantly, your certificate of attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and the YouTube version of the recordings, as well as the relevant documents that Izzy and myself showed tonight. If, after you leave tonight, you do want some post-webinar follow-up, please feel free to call TI Australia on these numbers or email them. If you do want to speak to Izzy or myself, then I know that they'll put you in touch with us, because we're all practicing teachers, we're all using this technology, and we just want to share how we use it. And please share how you use it as well. There's a kind of nice feedback on the chat window, so that we can all get the best out of using that technology, and our students really enjoy and understand the mathematics that they're doing. So, sadly that brings us to the end of tonight's webinar. Izzy, thank you very much for everything you shared tonight. I know that I and the participants have really enjoyed what you've shown us, so thank you.
No worries.
I do apologise for running slightly over, it's making you feel a bit rushed, so I do apologise for that.
That's all right, I was stressing out a little bit.
And equally, thank you everyone for watching this evening. We do put these on for you, whether you're watching it live or on demand. Please complete that feedback, contact TI, and if we can be of any extra help, please get in touch. Thank you very much. Have a great night, and all the best for you and your students as they approach exam time. Thank you, and good night.
Thank you.